So yeah, why AWS? It's like same as previous slides. Global footprint. It's big. A lot of regions. Though you could still put a Cloudflare in front of it and be even better, but yeah, it's quite decent. And as I said, it's choice for us. And CDN, load balancers, scaling, Aurora. That's great stuff. Aurora is actually my favorite one because we recently did a very big migration and with zero downtime, pretty much. Like I think we had a couple of minutes downtime, and with Aurora. So CloudWatch X-Ray, Athena for observability, built-in infrastructure as a code support. That's like really, I think probably it's most decent one. It has API for pretty much everything except SSO for some needs, and there are some also like services that you cannot really fully cover, but it's decent enough. Couple of clicks it's okay to do. And they're compliant, so it's easy. I mean, AWS is compliant, so you can easily achieve this compliance. So mistakes when doing, you have to go with infrastructure as a code. It's decent. If you're in early stage startup, don't do that. It's an overkill unless you have I don't know, you have something that you can just one click and provision this whole thing, which we do already build. We did build for small, medium enterprises. So we basically, if startup comes to us and says, I want to build something, and there's a little bit potential, they will succeed. We would go with full-blown solution, which is not expensive, but it's like we can achieve in an hour. I'll demonstrate it. So, but infrastructure as a code is a silver bullet. So go chase that. It's predictable, you can version, you can always reason why and what happens and blah. So hopefully, I don't know how many is using infrastructure, how many knows what is infrastructure as a code? Okay, not bad. And how many, I guess, use it or not just knows? Okay, that's okay. So yeah, what is that? So it makes things testable, repeatable, safe. So and you can basically put gatekeeper, like you can have a CI that delivers everything, and everything will be auditable. So you will see what is going to happen to your system, diffs, and whatsoever. So it's very nice. So feel free to play with the development environment, but at the end deliver stuff to production. Unless you have an emergency, you want to fix it right now. So maybe, but even that is not something I would recommend do. And guard rails and stuff. So I already mentioned that. So, and the last thing is like again, cloudification. Like this is upfront investment. So if you want to build stuff, unless you have again modules you are using from a person I mentioned already, or other modules, so it can be a bit costly, but it's worth it if you want to really decently take care of some infrastructure in a company. So learn to do that. And so I'm always recommending Terraform because it's agnostic, so it's universal skill you can apply to any hyperscalers. In some cases, you can even build your own sort of stuff if it's, I don't know, super custom. So now it's time to do a demo video, but I doubt you guys will understand anything from a video because it's just like fast forward version of provisioning. The promise here is that, or whatever I'm trying to show is that within 1 hour, which might seem easy, it's possible to provision enterprise grade ISO 24/7 certified infrastructure. It's just 1 hour. You just copy stuff from a boilerplate that is accessible, like it's in GitHub. You can copy and just put some, I don't know, you want a RDS or queues or whatever, just copy those things and then up and then it happens. So I'll switch it on. It actually, I can try to explain what's happening. So Osgen, I don't know if he's around. He did this whole thing. So he basically, he's there. So he basically copied the boilerplate and customized stuff. This is running using Terraform Cloud because that's a thing of choice for us. We've tried TerraGrant, we've tried some other thing, and only TerraMate we didn't try. So why we need to do those kinds of things? Because regular CI doesn't let you to provision big infra, so you need to somehow split it into smaller chunks because let's say you want to change something small in one service, you don't want the entire thing to be recreated. So we use the Terraform Cloud. There we can modularize stuff, and so each component will be provisioned in own workspace. So it's easy to see, and it takes just a couple of minutes or less than a minute to provision new stuff. So in here, basically, Wolfgang did it from scratch. So he pushed everything. So Terraform Cloud started basically provisioning all components together. And so we try to layer stuff. So that's another thing. If you're doing infrastructure as a code, hopefully you guys try to, model this somehow. And so what we do, we just split it into infrastructure layer, like very basic stuff where you provision IAM stuff, SSO, accounts, whatever is necessary to put everything else on top of it. We usually employ like 3 different accounts: root accounts, dev account, prod accounts. Reason is that it's very secure and restricted root account where we store some audit stuff and sometimes backups. And then we have production account, which is less restricted. And in case something goes wrong, we can restore from root account. And we have development account where everyone can just do whatever they want. And inside those accounts, you can actually have separate environments. And I don't know how many you want: test, stage, dev, blah, whatever comes to your mind. So we layer it. So we have these accounts, and then we have basically we have a foundation, then we have accounts, and then we provision environments on top of it. That's also separate modules and layer. And then on top of it, we provision application layer actually, which is databases, queues, whatever is like has to have some sort of service name in it. So this timer on the side is showing actual time. It's sped up, as I said. So it's not ideal because there are dependencies, and Terraform Cloud is not great at dependency management. So you have to provision everything. In some things go in parallel, some things fail, and then you have to wait until everything else is like fully provisioned, and then just rerun the same stuff. It would so that's probably our case. Maybe we can solve it, but yeah, what else I can tell until video is running. I'm trying to. Okay, let me just fast forward this to the end. So this demo is provisioning basically an application, like full-blown. You can see this is Strapi, Node.js backend. I don't know if you guys know that. So it's very good CMS, CMF kind of thing, which we normally always put at the backend and tell developers to use that. And then we'll put the front end on top of it. So this is provisioned, as you can see. So it's not just provisioning infrastructure, but also provisioning some basic application services that then later developers can extend. So if I can switch this on. Yeah, so this is already front end running. You can see it's deployed to CDN and it's fully functional. And then Wolfgang did create in the recording, he did create a user in a backend application so that he can access it because there is no registration process. It's very basic front end. So you can see he logs in and it's functioning. And it's deployed on AWS CDN, so fully functional. And then alongside, we also bring a Grafana. So we also provisioned full-blown observability stack, which is Grafana stack with Loki, Tempo, Prometheus, and Grafana on top of it. And you can see there's also a dashboard. So whatever is on the right side, yeah, those are the charts showing vitals from CloudWatch metrics. That's a like load balancer that put on front, so you can see the metrics from there, and the boxes in the middle is, yeah, basically metrics from the applications themselves. So, and then video is over. Yes. It's just whatever we bring provision, it's already patched and made. We basically scanned it a couple of times and made sure it's like secure enough. So, okay, so here, yeah, open source. I slightly touched it. So everything that I've shown here and I've spoken about, it's in a GitHub. It's also using the modules I've spoken about. So feel free to use them. And we have two parts, the boilerplate, which provisions everything, and we have also individual modules for different components. One thing I want to touch here, our approach is opinionated, like difference between generic and opinionated approaches. So Babenko's modules are more like, it's open, you can do whatever you want. It's very much reflecting the APIs of the hyperscalers. What we do, we simplify it for developers. We just limit it to very, very little configuration they can supply to avoid all the mistakes I've mentioned, like to not end up with snowflakes, because if you let someone customize stuff, they will end up actually customizing, and you have to deal with those many sorts of problems. So you can scan if you want, or you can search for DasMeta's GitHub modules and use them. It's not in perfect shape, so we're trying to keep it like properly documented, but so feel free to, people open PRs, so feel free to, I don't know, correct them, fix them, and open PR. So, and then, infrastructure as a code I slightly mentioned. So I know some people come from operation side, some come from just the Terraform beginnings. The Terraform didn't used to be as good as it is now. So try to organize your stuff. And we just, since it kind of gradually evolved the whole thing, we ended up just pouring more and more stuff. So that doesn't work. Eventually, you cannot split them. You cannot maintain the components. So have it modularly designed. Even if you are doing something for your own, you can still do that. It's easier to deal with, easier to test. Have layered architecture, whatever I've described. So try to, I don't know, if you are not sticking to whatever I proposed, stick to your own layering, but layering helps. Like I can tell you the specific use case. We had one infra where we would deploy many tenants. I don't know if you know the concept of the tenant, but basically copies of the same stack. And if you don't layer it, you end up just provisioning entire stuff like a copy, and you can end up with multiple EKS clusters, multiple RDS, and you don't have a flexibility to co-locate them. As a result, you're creating a lot of business, lot of cost, and that's critical for business. So multi-tenancy is like, try to always go there. Only cases you cannot is like, I don't know, compliance reasons. One customer is a bank, they want stuff to be on their own premises, so your code has to have the ability to deal with that. But layering helps with co-locating different tenants or different stacks, like dev stage, for example, can be co-located in the same cluster if you write the code right way. So I promised to be kind of like a businessy, political, but went into the technicalities. So security compliance as a code, you can enforce it with many Terraform tools. Try to have it in your CI to check stuff, and then policies and sanity checks. I don't think they are very much popular. There's Sentinel, and also one from HashiCorp, also tools. I don't think people use it that much, but with those tools you can enforce some sort of requirements, not to end up with messy configs, labels applied, structures are correct. So if you are designing modules, follow those. Automated testing. Oh man, this is a really painful part. So in the beginning, when Terraform had own tests, we were using that, and then people come up with some weird way of testing stuff. So testing actually is supposed to be very simple, declarative. Like with Terraform, you should be able to declare your cases, but they made it very weird. Like you would use a weird programming language to test it. So again, if you're designing modules follow those. Make sure it's tested, because new cases come, and then you are not sure if old cases are covered. So when you at least describe those, at least you give a chance the developer who is patching your module go back and test the cases you had before. So it's kind of a way to document the requirements. So if you can automate, write a test that could test it, it's great. If you can't, at least try to document those, and stick to the Git-baked workflow, which is, again, having CI doing all this process for you. We even have some sort of AI that reviews our PRs and gives a summary and suggests some changes. So everyone is talking about Gen AI, more of a copilot, so try to use those.